So let's apply. So what does all this mean? Why do we care? Well, this factors into the melting points of fats and oils. And if you think about it, I love coconut oil, okay? In the summertime, it's liquid in the container, but in the wintertime, it's solid. So this has to do with the length of what that fatty acid is. And so a fat is usually solid at room temperature, and it usually comes from animals such as meat, whole milk, butter, and cheese. Where an oil, think of avocado oil, right? This is usually liquid at room temperature, and it's usually obtained from a plant source, such as palm tree or coconut oil, okay? And so, like I said, the coconut oil, sometimes when it gets cold in my house, it can solidify. All right, so oils from olive and peanut, they're unsaturated. Mono meaning one, unsaturated meaning a double bond. So that means that it has one double bond in it. And they contain large amounts of oleic acid. Corn, cottonseed, safflower seed, and sunflower seeds, they're polyunsaturated because they contain large amounts of fatty acids with two or more double bonds. Palm and coconut oils are solid at room temperature because they consist mostly of those saturated fatty acids. So remember the saturated ones, it's like playing Tetris with sticks, right? They stack really easily. And so when they stack easily, it's easy to become solid. So why do we care? Well, this is talking about our melting points, okay? So saturated fatty acids, they have a higher melting point than unsaturated fatty acids because they pack together more tightly. Think of, again, those Tetris, or trying to pack spaghetti noodles versus spiral macaroni, okay? They're going to pack differently. Same thing. If they have kinks in them, it's going to pack a lot differently than just a solid straight line. And the saturated fatty acids are usually found in animal fats and in that coconut or palm oil, okay? And so when we have the double bond in it that causes a kink, remember that's going to be the unsaturated. Or if it's a straight with no double bonds, then that will be the saturated fatty acid. Okay, so looking at the percent saturated and unsaturated fatty acids in fats and oils, vegetable oils have low melting points because they have a higher percentage of unsaturated fatty acids than animal fats. So you can see here, the yellow is polyunsaturated, red is monounsaturated, and then the blue is saturated. So you can look and see beef tallow, butter, coconut. Butter's my favorite. Okay, then our olive, canola, soybean oil, etc., and the differences that they have. So moving on to apply this to chemical properties of these triglycerides, okay, or triacylglycerols, same thing. Many soft margins, stick margins, and solid shortenings are produced by the partial hydrogenation of vegetable oils, okay? And so what does that mean and why do we care? Well, we're going to learn to draw the condensed structural formula for the product of the triglyceride that undergoes hydrogenation, hydrolysis, or saponification. Okay, lots of big words. So, hydrogenation. Okay, in hydrogenation reactions, the double bond in an unsaturated fatty acid reacts with hydrogen gas to produce a carbon-carbon single bond. And those hydrogen gas is bubbled through the heated oil, typically under the presence of a nickel catalyst. And so what does that do? Well, when the hydrogen adds all of the double bonds of the glycerol, triolate or trioletin, to a nickel catalyst, the product is a saturated fat, glycerol tristerate. Okay, so it puts these, it takes these double bonds out, okay, and it makes them into single bonds. And so you would have glycerol triolate versus glycerol tristerate. So it changes what's going on. And like I said, the carbon numbers are going to be like the same, right? So just it's going to change the physical property of it. So in commercial hydrogenation, okay, the addition of hydrogen is stopped before all the double bonds in a liquid vegetable oil become completely saturated, where partial hydrogenation of a liquid vegetable oil changes it from to a soft, semi-solid fat. And the more saturated product has, the higher the melting point it has. So we can take vegetable oil here that are liquids, hydrogenate it, right, and make it into a soft spread. Okay, so you hear about hydrogenated oils, partially hydrogenated oils, etc. And so this is what they're actually talking about and how they chemically do it. Okay, so what are the products that are obtained from the complete hydrogenation of glycerol triolate. Pause me and come back. Right, what did you get? It would be B. Okay, so glycerol triesterate would be your answer. All right, fantastic, guys.